In this video, we are going to see what are spherical triangles. The, the planar triangles precludes the spherical triangles. In case of planar triangles, we discussed the bunch of formulas like triangle inequality, sine rule, cosine rule, blah blah blah, and so on. And in case of planar right angle triangle, we are mostly concerned with the Pythagorean theorem. So the Pythagorean theorem actually states that the sum of the squares of two sides is equal to the sum of the largest side. So if we let the largest side to be c, we are going to get a square plus b square equal to c square. That's what Pythagorean theorem represents. So basically there are many branches of trigonometry exist, that are planar trigonometry, spherical trigonometry and hyperbolic trigonometry. We are basically concerned with the planar trigonometry, and in some cases we are dealt with the hyperbolic trigonometry, but we are not concerned with the spherical trigonometry in our curriculum. So let's see what are the basic elements of the spherical trigonometry. The spherical trigonometry starts with the spherical triangles. So let's see what the spherical triangles are. So it is the mini globe. Rather, it is the keychain I have bought the last month. So as you can see over here, the center part which divides the earth into two equal hemispheres. The two equal hemispheres are named according to the positions as northern hemisphere and southern hemisphere. So the India is located in the northern hemisphere and Australia is located in the southern hemisphere. So it is the basic fact. So the triangles drawn on spherical surfaces is what we call the spherical triangles. So let's see. In the case of spherical triangles, we are barely need the great circles drawn on the spherical surface. So let's see. And you all know that the equator is a line which passes through the center of our earth, right? If we extend the concept and draw somewhat like this, we are going to get what is called the great circle. I draw I draw the full circle. The half of the circle is drawn dark, and half of the circle is drawn like dotted points, with the dotted points because of the fact that the half of the circle is present beyond our view. So I drawn something like this. So it is the great circle which passes through the center and divides up the earth into two equal parts, that is northern hemisphere and southern hemisphere. So I have drawn three great circles which passes through the center, and at the same time it divides up the earth into two equal parts. So as you can see here, the three great circles, each great circle passes through the center and divides up the earth into two equal parts. So in case of this this great circle divides up the earth into two equal parts, that is this one and this one. So this great circle divides up the earth into equal parts, this one and this one. And the equator, as you all know, the divides into northern hemisphere and southern hemisphere. The region bounded by three great circles is what we call the spherical triangle. As you can see in the figure, I shaded the spherical triangle somewhat like this. So we are dealing with only the spherical triangle in the 2D plane. So we are actually going to Gemba. So as you can see in this balloon, I have made three great circles which passes through the center, as this one represents the equator and this one are respectively this one and this one in the figure. So as you can see here, this portion is what we call the spherical triangle, and it has got the vertices A, B and C. The angles in the spherical triangles ranges from 180 degree to 540 degree. The sum of the angles ranges from 180 degree to 540 degree. In case of planar triangle, the sum of the angles can't exit 180 degree. It is always 180 degree. But in case of spherical triangle, there is a range from 180 degree to 540 degree. Let's wind up the video. Let's see in the next video. Thank you.